or Python from zero, where I'm just going through extensively every possible thing you can do with Python, trying to start it kind of in a beginner's mindset. And last week I covered lists, and this week I'm going to dive into control flow, which is a fun topic. And let's go ahead and share my screen here. And so you can see that in terms of Python, in fact, I'll just take this out and get to full screen mode here. That um, control flow, there's a lot of different fun statements, if, for, pass, all that stuff. Let's see how much we can get done today. So I'm gonna start out with a collab notebook, which I think is good for this kind of stuff. And I'm going to create a new notebook. I'm going to call this one control flow. And let's go ahead and put this in control flow here. Now I do have some cool little tricks here in terms of runtime. I can make it high RAM, right? Why not? Let's make it have lots of energy in case I do huge for loops or something. And then I'm also going to uh, build this out at the beginning, say control flow, so that I can create like a hierarchy of different things. And we can see like what are the things we want to do. We want to do if, for, range. Those look good. So we'll do let's see here. Let's see like um, if, for, range. We'll do break, pass, match. Break, pass, match. Break, pass, match. There we go. So let's get into it. Let's go here and we'll go for if. Okay, so if, I think, is in some sense one of the funner ones to play around with, because in Python it's very short. And so one of the ways you could test out an if statement is to actually make something either be true or false. And so you could say, for example, statement is equal to true. So we make a statement true, and then what we could do with it is kind of play around with it. And so how would we do this? Well, we could say if statement, and so by default, it would kind of essentially evaluate the true. We could say prints like this was true. That, and basically that's how if works, is you can shortcut it, and basically if it evaluates to true, you're good. Now if I said um, you know conspiracy or something, which is definitely something that our times have had a lot of, is let's double check I'm spelling it right. Conspiracy looks good. Okay, I'm always so scared I'm going to not spell something correct. We'll say equals false. Then what we could do is say if conspiracy, prints, I don't know, like this is something that I heard, or whatever, some kind of statement. Now notice what happens is nothing happens, because the if statement notices that this is false. And so as a result, it doesn't do the following thing. So you can use the shortcutting to actually build a lot of really cool stuff as a result of using the if statements here. And it also works with like something being empty or not. So like if I said, you know, um, container or something is equal to, and I said like there was nothing in it, I could say if container, since this was full, but it's empty, so nothing happened. Likewise, if I make one like full container here, we can actually say like like this has many things in it, right? And then if I say if full container could say prints this had things in it. Right? So this style, I think, is maybe not that known, right? Is that basically this concept of something being empty or true, sorry, empty or false or true or full is a really amazing way to actually do conditional statements and do flow for things that you're doing in your application. So I think this is one of the ways I personally would use an if statement. Now, that's basically like the simplest possible if statement, but most of the time people are using if with other things as well, and especially with else. And so, what could we do? Let's actually add some if else here. And we could say maybe build out some fruit. So we could say you know fruits 1 is equal to apple, and then we could say fruits 2 is equal to pear. And we could say if fruits 1 is equal to apple, so then we can also do these kind of equality statements. We can say that prints, say, I love apples, but we also could say, um, you know, else, prints this fruit is good too. So in this case, it's only going to hit this one because it's true. Now, if I change it, if I make this like a strawberry, and we can actually even put in a little templated statement here, we can do this, right? So we can see each one, right? So we can say, right, it didn't run this because it didn't match that statement. So these are really actually, just to keep things really simple with if else statements, these are probably the two things that you care about is like first, evaluating if, second, doing some other statement with if else. That's it. Okay, so that's the if else. So let's move on now to for. Now for the reason, I mean, this is one of the classic programming things to do is to do a for loop. Why do you do loops is to work on things. And in particular, one of the easiest ways to create a for loop is to use a list or to do a range. Let's start with a list first, and we can build one called fruits here, and we can do this. Say, apple. You can say pear. And we can say banana. Like that, and I don't know what else. Strawberry. There we go. And we can just say for fruit in fruits, prints fruits, right? Like this is classic for loop, goes through a list, prints stuff out, right? Everybody should have this mastered. This is called an iterable, right? Because you can iterate through one by one and loop through it. And like, even though it's simple, it is basically a an essential component to all programming is to understand and master the for loop. Now, there are a couple things that are maybe a little bit counterintuitive, like you don't always want the loop variable, right? And so this gets swapped out each time. So what you also can do, if you wanted to, let's say, count the things that are in a for loop, what could you do? Well, we could do this. We could say count is equal to 0. And then we could say for, and we could do this, right? You could say underscore, and this will just nuke what's happening in here. We say for underscore and fruits, what we could do is we could just count the number of things that we've looped over, and then at the very end, or while we're looping, either one, we could just say like something like this. We would say there are a total of, and we just put in the count variable, right? So this is another way to handle it. There are a total of, fruits, that just because you have the loop variable doesn't always mean you need it. And in fact, especially in a large program with a large loop, you may want to get rid of this because of the fact that it's going to consume memory and resources and it's going to slow things down. And so if you don't need it, just get rid of it, right? So that's kind of the core concept for that. Now, another kind of loop that you do see as well is like the key value loop. And so let's show that as well. And so what you could do is you could say meals, and we could create a dictionary. And instead of this, we would just do something like dinner, have a steak. Although in this economy, let's change that. Let's change this to tofu, right? Nobody's got money for steak. And lunch, you can do salad. That looks also inexpensive. And then also for breakfast, we're going to go intermittent fasting. So we'll just say black coffee. So we have a set of things here. Now, how do I loop through these things and build something out? Pretty simple. I would just say for key, or in this case, we'll say for meal, um, for meal hour, and for food, meal in meals dot, and this is where I would say items. This would basically unpack the key, and this is the key, this is the value. I can then do things with it. So I can say, you know, uh, for this meal, put in the meal hour. I eat this type of food, just something like this. And then we would just go through here and we would just do food like that. Now, there we go. You can say for this meal, dinner, I eat this type of food, tofu, for this meal, lunch, right? So you can see how with looping here, I can both interact with the list and I can also interact with the dictionary. They're both easy ways to go through things. Now, what about range here? Pretty straightforward as well. Let's go ahead and build that out. Let's go ahead and say text range. So what range does is it's pretty straightforward. It gives you an iterable that goes from some range. There we go. Give me something from 0 to 100. Now it keeps it inside of there, and so what I would have to do is I would have to say for item in range 0 to 100 prints item, and now it's going to print 0 to 99. There we go. And print all those values. Now that's a little excessive. Let's go to 10 because I don't want to get like too much print output. And so if we go here, there we go, 0 to 9, right? Because it stops at 10. And what we can see as well is if we say type here and we say range, 0 to 10, it'll tell us that in fact it's a range type, and a range type it will return back an iterable. In fact, we can tell that by doing this range question mark, and it says return an object that produces a sequence of integers, right? And so we can get all of the documentation. So range also is heavily used in control flow. What else we got? We got break. So break's a good one. So let's go for break here, and we'll go break. How do we use that? So you could do this. You could say for I in range 0 to 10. You could say if, let's get rid of that, annoying. If I, so we're using everything now. So if I is less than 10 prints I, else break. Now let's go to 5. So basically, as long as I don't have something above 5, then it'll still work. Otherwise, break out of the loop. And so this is just an easy way to just break out of a loop. So it'll only go 0, 1, 2, 3, 4, right? So that's the core concept with a break, right? You break out of some condition. Now, what else we got? We got the pass. Now, pass is an easy one because it's a no op for lots of different things. And so if we go to pass here, how do we use pass? Here's an easy one. We can do def no func, and then we can say here pass. There we go. That's one of the ways you use pass. You just say don't do anything. You can also do the same thing with a class. Like you can say class foo pass. Now I do use this actually a lot because if I say f equals foo, right now I can actually add things to it because I can go f.id equals 1, f.color equals blue. So this actually is kind of a cool thing, right? Because then now if I go f.under dicts, look at that. I got myself a class that I can play around with. So this is probably one of the things that I would, recommend playing around with pass. Got one last one here, match. And with matches here, I don't personally use this that often. So this is a new feature, I believe, to Python. Yeah, I was like, "Whoa, I don't remember this." This is in 3.10, but the concept is essentially a case statement. And so, um, what we can do here, I guess, is just copy that, and we just say match point case. What's the easiest possible? You can combine several literals in here. So I mean, basically, yeah, it's just a case statement, and I'll just put a link to the docs to do for people to take a look at case statements. I mean, I've used them in other languages like Erlang in particular. I use case statements all the time, and we'll just put some docs to that. So you can see here that control flow, not too bad in Python. I'm going to take this and I'm going to save it in GitHub. And this will be a great lesson to really rapidly go into control flow with Python. So let's go ahead and check this in. All right, assimilate Python. Where is this? There we go. Perfect. All right. Well, next week I'm going to cover, what am I going to cover next? We did functions. I love functions. Yeah, let's get into functions next week. All right. See y'all next week. Thank you for attending.